First graph is distance type graph. You can see here we have time along a y-axis and distance along y-axis and time along and this graph our time and distance is going to be uniform, so ultimately our speed is also going to be uniform. So now how do we find out what is the speed? We can find the speed individually by doing 60. We can find the speed individually by doing 40, 20 by 40 and 40 by 60. But how do we find the speed in particular area, or is it uniform or not? So for that we are going to draw parallel line to y-axis through point A and through point B as time representation, and we are also going to draw parallel line to the y-axis through point B and through point A as representation of the distance. We are going to name this T1 and T2, and this will be S1 and S2. This will be the new distance and this will be the specific time, and this point will be C. So now to find out the velocity, we have S2 minus S1 upon T2 minus T1. So this is going to be our formula to find the velocity by distance time graph. So friends, this is the second graph, velocity time graph. Here we have velocity along y-axis and time along x-axis. We need to understand this graph is also for the uniform velocity. So you can see this, the velocity is 20, is uniform, but the time which is changed is can be T2 minus T1. This is our first time and this is our second time. So how are we going to find the displacement? We know that time into velocity is displacement. So the area enclosed by velocity time graph and the time axis will be equal to the magnitude of the displacement. So this area of the rectangle is going to be our displacement. So how do we going to find that the displacement? So we have formula to find the area of rectangle, that is length into breadth. So our length is velocity, that is 20, and our breadth is time T2 minus T1. So friends, here is our answer. 20 in bracket T2 minus T1 meter square is the formula, but our main formula is going to be like this: AB into CD. This what you need to remember is that to find the displacement in velocity time graph, all we have to find the area of the rectangle, which will be AB into BD. This is also velocity time graph, but in this graph the acceleration is uniform. So to find out, we will going to draw the line from A to D through these points parallel to the x-axis, and same for E through point E. We are also going to draw a parallel line from E to C parallel to the y-axis as the velocity. This time how are we going to find displacement or distance here? So for that, last time we had we took the formula for area of the triangle. This time we are going to take a formula for area of rectangle plus area of triangle. So as far as we can see now, the rectangle is A, B, C, D, and the triangle is A, D, E. So the formula for the rectangle is AB into BC, and for the triangle is half into base into height. This is the base and this is the height, and here this is the length and this is the breadth. So here is our third formula, that is area of rectangle plus area of triangle, that will be AB plus BC, AB into BC plus half into base into